What if I told you that right now, as you're watching this video, there are places in our universe so bizarre that they literally shouldn't exist? I'm talking about cosmic locations that defy the laws of physics, galaxies forming faster than possible, stars surviving explosions, and black holes that grew too massive too soon. These are places where the universe seems to break its own rules. And today, we're taking a journey through the most impossible regions of space, the ones that make scientists rethink everything they know about the cosmos. Galaxies that formed too early. GNZ11, a galaxy seen just 400 million years after the Big Bang, shouldn't exist. It's massive, luminous, and already full of heavy elements like carbon and iron. But galaxies of this size, by our models, should have taken at least 1 billion years to form. Yet, there it is, shining bright at the dawn of time. Now, observations from Hubble and James Webb show that GNZ11 formed stars at an incredible rate, suggesting that the early universe played by very different rules, or that our understanding of galaxy formation is incomplete. Each new observation of galaxies like GNZ11 reminds us that the universe evolves faster, stranger, and much more creatively than we ever imagined. Dark matter defying galaxies. So some galaxies seem to ignore one of the universe's most fundamental ingredients, dark matter. Take Dragonfly 44, for example, made almost entirely of dark matter. Then there's NGC 1052 DF2, a galaxy that appears to have almost none. Now, according to physics, that's not supposed to happen. If dark matter is what holds galaxies together, how can something like DF2 exist at all? Did it lose its dark matter somehow? Or was it born in an area of the cosmos where dark matter never formed? These galaxies make us question whether we even understand what dark matter truly is, or if there's another hidden force shaping the universe. Supermassive black holes in young galaxies. TON 618 is home to a black hole so massive it weighs over tens of billions of suns. And here's the crazy part. It formed when the universe was still a baby, less than 1 billion years old. How can an object so huge form so fast? Now, even if you feed black holes at the fastest possible rate, they shouldn't reach this size that quickly. Did early stars collapse directly into black holes? Or did we miss some secret fast growth mechanism happening in those first cosmic years? Early supermassive black holes defy every timeline we've built, and hint that the early universe might have had shortcuts to create monsters beyond our imagination. Neutron stars at extreme density. Now, imagine crushing 2 suns into a ball just 25 kilometers wide. Well, that's PSR J0740 plus 6620, one of the heaviest neutron stars ever found. Now inside, matter is squeezed into states we can barely describe, perhaps even into pure quarks or other exotic particles never seen on Earth. And others, like XTE J1739285, spin hundreds of times per second, faster than physics should allow. Now, these objects push the limits of our theories, creating natural laboratories where the universe tests what happens when matter itself is pushed to the edge of existence. Planets around pulsars. After a supernova, the star that remains is a pulsar, a rotating corpse emitting deadly radiation. So how in the universe do planets exist around one? PSR B1257 plus 12 hosts several planets orbiting a pulsar. Did these worlds survive the explosion or form afterward from the wreckage? Well, either way, they defy logic. And then there are hot Jupiters like WASP-12b, roasting so close to their stars that their atmospheres should evaporate. But somehow they endure. Black holes in unexpected binaries. M33X7 is a binary system that shouldn't exist. It contains a black hole far heavier than its original star should have produced, orbiting another massive star in a perfect cosmic dance. And to make matters weirder, their spins are misaligned, hinting at a chaotic and violent origin story involving magnetic fields and mass loss that don't match our current models. Systems like M33X7 help us study relativity, stellar evolution, and gravity at its most extreme, but also remind us nature loves to bend the rules. Cosmic voids and great walls. So, the Boots Void is an enormous bubble of nothing, hundreds of millions of light-years wide, containing barely any galaxies. And meanwhile, the Hercules Corona Borealis Great Wall stretches over 1 billion light-years, the largest known structure in the cosmos. These two extremes, near total emptiness and a galactic megastructure, shouldn't coexist, or at least not according to simulations. Yet, here they are, revealing that the universe organizes matter in ways we still can't fully grasp. Early metal poor stars. Stars like HE 01075240 and HD 140283, the Methuselah star, are almost as old as the universe itself. They contain hardly any heavy elements, meaning they formed soon after the Big Bang. But how did they survive for over 13 billion years? These ancient survivors shouldn't even exist under normal stellar physics. They're relics of cosmic dawn, fossils of the first generation of stars that ever lived. Extreme exoplanet environments. So Kelt 9b has a day side hotter than some stars. At those temperatures, molecules break apart. Yet this planet somehow keeps an atmosphere. Now, how is that possible? Maybe magnetic fields, strange chemistry, or unknown mechanisms hold it together. Planets like these teach us how far material and atmospheric science can stretch before breaking. They're proof that even in the most hostile corners of space, nature finds balance in chaos. Interstellar objects. In 2017, astronomers spotted something strange, an object passing through our solar system that didn't come from here. They named it ʻOumuamua. It was long, fast, and moved in a way that didn't match comets or asteroids. It released no gas or dust, but still seemed to accelerate as if pushed by some hidden force. It's the first known visitor from another star system, and we still don't know exactly what it was. Rock, ice, or something else entirely. Regions of fast radio bursts. So FRB 121102, a region in a distant galaxy, emits powerful, repeating bursts of radio waves. And each one lasts milliseconds, but releases more energy than our sun does in days. We think magnetars may cause them, but their patterns vary wildly, and no single explanation fits all. These bursts are windows into the most extreme electromagnetic conditions in existence. Once again, the universe reminds us, when it comes to space, the impossible is often real. Now, if this journey through the universe's most impossible places amazed you, hit like, subscribe, and share it with fellow space lovers. Because every discovery, every galaxy that forms too fast, every black hole that grows too big, shows us that the universe doesn't just follow rules. Sometimes it breaks them. And that's where the real magic happens.